Hi, my name is Andreas and I'm a senior software engineer here at Blueye. Today we'll talk about how to get the most accurate position estimate by using one of these DVLs from Waterlinked. A DVL is short for Doppler velocity logger. So the sensor is sending 4 acoustic beams towards the seabed and is then using the Doppler effect to estimate the vehicle's velocities. When we know the velocities, we can use a method called dead reckoning to estimate the drone's position. Dead reckoning is the process of calculating the ROV's position relative to a known starting point and heading. So how accurate is this? The accuracy can be divided into 4 components. The first component is the initial starting point. If the starting point is off by 10 meters, the whole track will be off with the same offset. The second component is the initial heading during reset. So if this initial heading is off by 6 degrees, it will be off by 10 meters when you are 100 meters away. The third component is the drift in the accumulated travel distance. This is about 1%, which means if you travel 100 meters, you would be off by plus minus 1 meter. The fourth component is what we call the heading drift. The heading drift will typically start curving off the position instead of going in a straight line. So this is typically the dominating component as time goes by. So we really want to minimize all these 4 components as much as possible to get the best possible position estimate. So now I will show you how to do this in the app, but before that we have to put the drone in the water. Okay, so now the drone is in the water. I'll just find a known point that I can correlate with the map. So in this case, I'll select the corner of the waterfront here because that's very easy to also find on the map. And now the drone is facing exactly the corner. So I just go into the menu and navigation. And now I want to create a point of interest on this corner. It's here called point 4. You can also rename this point. Let's call it start. So if we go over to settings, you see under dead reckoning, we can here select the start point coordinate. So instead of using the tablet GPS, I now want to select our starting point of interest, which is start. Nice. So then we have the starting position, but we also want to give it an initial heading. So here we have 2 options. It's either the drone compass, which will then just take the heading shown in the heading bar here, or we can be more precise and give it a manual heading. So in this case, I have checked on the map on beforehand that the heading of the side of this corner is 204 degrees. So here 0 is straight north and 180 is straight down, so this line here would be 204. So then we can just double check that the drone is pointing exactly that direction. There you go. Now you can also see that the heading of the drone is 230, so it's actually a bit disturbed by the large steel structure here, which is also very magnetic. So now we can just go into the navigation tab again and then hit reset position. You want to start a new position track with the initial heading source manual, and the reset position point is start. Just hit confirm. Now you see the drone is rotated correctly and at the pin where we selected. So now we can just fly around and find new objects. So now we can see we have traveled a little bit to the west, and this is where the mooring blocks are located. And again, it's very easy to add new points of interest by just pressing this Blueye button. Or you can also enter coordinates manually by hitting the edit here. You can also change the depth associated with this position. Cool. So let's say we've been diving around for 15-20 minutes and the position is starting to drift away. Then you could simply go back to the starting point. And then simply hit reset position again down here. But now you see it's not necessary because it was a really short loop. If you want to check out more detailed information on the position estimate, you can go to status. And here you see a bunch of data. So top left shows you all the data related to the position estimate. It has a local position in the meters north and east from the starting point. It also shows you the heading that is reported from the DVL. Next is the lat long of the drone, lat long of the operator, and also if the GPS is enabled on this device and its accuracy. Below that you can read the velocities reported from the DVL. So this can be used if you want to, maybe you want to measure the water flow in the river, then you can just disable station keeping and let it flow down, and then you can read here the velocity. Or you could see how fast you're driving forwards, for instance. You can also see the turn rate if you're turning, and yeah, basically nice speedometer to have. The environment BS estimate is an estimate of external forces. So if there's a force in the tether, or if you are putting on station keeping in the river, this number will increase. Next is the traveled distance odometer. So it's basically just a counter that counts the number of meters traveled. This is very easy to reset if you want to measure a distance of a pipe, for instance. Then you just reset the odometer and then you can drive forwards for a couple meters and then you can easily see how far it is over here, for instance. Now it's at 4.3. Then you can always reset it again. On the top right here you can see navigation sensors. It will list out the connected positioning systems. So in this case it's only the DVL A50. But if we were to connect a UGPS from Waterlinked or an NMEA device with USBL positioning systems, they will also get listed here. And the green light is indicating that it's valid. The two last sections are related to the mission planner, which is covered in a separate video. Also here you can find the same reset position button, which is the same button as the lower right one here. These buttons you can use to focus the map on the drone or on the operator. And also, every time you hit reset position, you will actually get a new track in the log file. So this can be convenient if you have multiple runs or multiple inspection jobs. It's always good to have short and nice position tracks, because then it's easier to delete the parts that are not relevant. So every time you reset the position, you will also get a new chapter in the exported position file. So now I've shown you the required steps to get the best possible position with the DVL A50. However, if you do need a good position for longer operations, we recommend that you connect an external positioning system. This could be an USBL system or an UGPS system. Both of these will then be integrated in the app the same way and appear here under navigation sensors. You can also use a DVL together with the USBL. Then the two sensors will be fused together to give you the best possible position estimate. So that's all I had on how to reset position and how to get the best position estimate with the DVL. If you want to explore more with positioning, I would recommend that you check out our mission planning videos. By having a good position estimate that you learned how to do in this video, it's also very cool to start going to points and executing missions. See you guys around. Bye.